So once again, our agenda for today, warm-up number 3. We're getting, and by the way, last week, I know it said on the screen warm-up number 3, but it was actually warm-up number 2. Now it is number 3. Number sets and expressions, we're going to continue and finish today because we got to move on. Number 3, we're going to have 6 problems to simplify expressions for home plate. Hopefully you worked on the 8 that I left last week. I just wanted for you to get a feel as to what they look like in regards to the practice, and hopefully with the review for today, that'll help you double check your work for those. Okay. All right, let's move on. So warm-up number 3. I want you to do numbers 2 and number 3, and it reads: find the sum, difference, product, and quotient of -18 and 23. And number 3 says find the sum, difference, and product and quotient of -7.5 and 2.3. So work on those. And once again, in case you forgot, sum means addition, difference means subtraction, product means multiplication, and quotient means division. And you need to do those operations for the 2 numbers given. So work on that, please. Copy that and go. Alright, so check your work. There are the answers for each one. And let's move on. Alright, so for those of you that are following along on YouTube, there's your Nearpod code, your synchronous session. It's YSPOI. That's your login code. And remember, start with your period number, then your first name, and then your last name. And you can actually move the screen and follow along. Also, just whenever you hear me say copy this or copy that, you can pause the video at that time so you can copy stuff. Okay? Alright? Alright, here we go, guys. Let's continue. Once again, materials needed. You're going to need your graph ruled paper, notebook. Make sure you get that as soon as you can. Number 2, pencils, highlighters, 4 colored pens. And you're going to see today when I start using different colors, you're going to need to have those handy. It helps. And also your assigned textbook. So the question was, some of you have been emailing me, Mr. Q, are we going to need our textbook? Yes. They have it at the library, volume 1. They might have volume 2, but if they don't, at least get volume 1. They should have it there. Okay? And if they have both, then get both whenever it's your time to go. And I know today they have, I think, 11th grade going to get their textbook. So, all right, let's move on. Our home plate for last week were the 8 problems. We're going to revisit those, but copy today's home plate. Today's home plate is on the screen, and it reads simplify. And we have numbers 1 through 6. Number 1 reads -5 plus 3 plus -1 plus, instead of 4 on that last term, guys, make it -4. -4. This one, -4. Number 2, 6, make that a -6. Plus -4 plus -5 plus 7 plus -6. Number 3, 3 parentheses, which means times -7 plus 5 close parentheses plus 10 minus 1. Number 4, 2x plus 5 plus 6x plus -8. Number 5, 6y plus 2 plus 3x plus parentheses -2y plus -5 plus 4x. Number 6, 1 minus 7m plus 2x squared plus 10a plus 9m plus -8x squared plus -6 plus a. Copy that. I'll give you guys some time. Notes and get caught up by viewing the video. Alright, here we go. Our objective for today, I can simplify algebraic expressions. Once again, I can simplify algebraic expressions. If you're using the same Cornell note as last week that we started, that objective should have been at the bottom left of your paper. Yes? If you started a brand new set, then you need to copy that. And once again, by looking at it, question, what is the concept for today? And if you notice it's in green, what is the concept for today? Algebraic expressions. Today we will get to those. Last week we didn't. And what are we doing with that? We're simplifying. We're still simplifying, guys. Alright. Next. We covered last week and we said we cannot solve expressions. But what are the three things that we can do with expressions? We can translate, evaluate, and simplify. You guys remember that? And I went over an example all the way through. And then from there we covered the sets of numbers from real to imaginary to complex. And I said for real numbers are broken into two sets. The sets of rational and irrational. Rational, they can be made into fractions or decimals. Irrational cannot. And within rationals, we had counting, whole numbers, and integers. You guys remember that? Yes, Mr. Q. Good. So all of these could be made into fractions and decimals. These cannot, and I gave you guys these as non-examples. From there, we got into imaginary numbers, and the first imaginary number I gave you was square root of negative 16, which becomes what? 4i. You guys remember that? And I said once we simplify to lowest terms, that means the square root of negative 1 is the letter I for imaginary. And from there we came up with complex numbers. What were complex numbers? It's made up of one real number and an imaginary number. You guys remember those? One real number and an imaginary number. Put them together, it makes a complex. Alright? Alright. So, from there, I covered the additive inverse property. The additive inverse property said what? A number plus its opposite equal to 0, 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 and we call them what? Zero pairs. You guys remember that? Yes, Mr. Q. Alright, good. So, from there, we moved on to the identity property of addition. What was the identity property of addition? A number plus 0 gives us the same number, a number plus 0 the same number, a number plus 0 the same number, a number plus 0 gives us the same number. Okay, so from there I introduced numerical expressions and I just showed you how to do simple stuff. Today I'm going to elaborate more on that. So copy this on your paper, example 1. Right now we're going to focus on numerical expressions. Numerical expressions. Here we go. Example 1. Negative 9 plus 13. So, what was the process that I showed you last week? I said between two numbers, when we're simplifying expressions, make sure there's addition. From there, check to see if they're opposites. Are they opposites? Yes. From there, we start with the smallest number, which is 9. So this is negative 9. It's opposite to 13. So negative 9 cancel 9 of these positives. So that means we're left with 4 positives. Number 2. Negative 15 plus 8. Do that one by yourself. Alright. Alejandro, what'd you get for number 2?
I got negative 6.
Close. Christopher, help him out.
Negative 7.
Negative 7. Let's double check. Is there addition between the two? Yes. Are they opposite numbers? Yes. Smallest number is 8. That means 8 of these positives are going to cancel 8 of these negatives, and we're left with negative 7. Hands, have you got that? Yeah. All right. From there, let's go to number 3. Let's kick it up a notch. Yes. Let's do 9 plus negative 5 plus, let's do negative 7. Alright, let's do this one together. Like I said, we already did some of these last week. That's why I'm going a little bit faster today. So if you feel that you need me to elaborate more, just go ahead and unmute yourself and let me know. So there's two ways of doing these. Here it goes. First way is as follows. You start with the first two numbers. Is there addition in between? Yes. Are they opposite numbers? Yes. So that means I'm going to start with the smallest number, which is this one. This one's going to cancel 5 of those, and we're left with positive 4. I bring down the plus and negative 7. Is there addition in between? Yes. Opposite numbers? Yes. Smallest number is 4. Cancels 4 of these, and we're left with negative 3. Now, I'm going one step at a time using the properties. However, what's the other way of doing this one? Look up, please. I'm going to combine like terms, so watch. Is there addition here? Yes. Addition here? Yes. So, are there any like terms? Yes. Negative 5 and negative 7. What is negative 5 and negative 7? That's negative 12. Plus, what's the other number over here? 9. Alright. Addition, smallest number cancels 9 of those, negative 3. So you should be at least doing one or the other, right? Yes, Mr. Q, we love these. Alright, good. Crank it up a notch, yeah? Alright. So you can either take this route, guys, or you can combine stuff and do this route. I'll leave it up to you. Let's go to number 4. Negative 1 plus 4 plus negative 7 plus 8 plus 6 plus negative 2. See what you get for that. Copy that and go. Alright, so Mia says positive 8. Let's double check. So I'm going to do check first to see if there's addition throughout. Yes, 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 and yes. I'm going to combine like terms. I'm going to start with the negatives. Negative 1, combine it with negative 7, that's negative 8. Combine it with negative 2, that's negative 10. Okay. Next, positives. 4 plus 8, that's 12, plus 6, that's 18. Alright. So, is there addition in between? Yes. Opposite numbers? Yes. That means 10 of these cancel 10 of these, and we're left with 8 from the corner. Let's go, Mia. Alright. So we're good, yeah? Alright. You're like, Mr. Q, come on. Give us a challenging one. Alright, we'll get to the challenging ones. So, one thing that I want you to notice, though, look up to the screen. Notice that, look at all these expressions that we did. These are known as what? Numerical expressions. Look at them. What do you see numerical expressions have or only have? Look at them. What do they only have? Were you thinking numbers and operations? Yes, that is correct. Numerical expressions only have numbers and operations. Which brings us to today's main idea. What's today's main idea in your Freire model? Algebraic expressions. Write those down, please. Algebraic expressions. So we're going to start cranking it up a notch now. What are algebraic expressions? Well, algebraic expressions are expressions that contain variables, numbers, and operations. Algebraic expressions contain variables, numbers, and operations. Algebraic expressions contain what? Variables, numbers, and operations. What do they have? Variables, numbers, and operations. What do they have? Variables, numbers, and operations. Alright. Fairly simple, straightforward, yes? Yeah. Examples. X plus 3, m minus 7, 2 times y, k divided by 5. As you're writing them down, think about it. Are these algebraic expressions according to the definition? Do they have a variable? Yes. Do they have numbers? Yes. Do they have operations? Yes. That's why they are algebraic expressions. Alright? So now that we know what they look like, let me show you what they are not. I'm going to show you what they're not. Over here, none examples. Copy those. X plus 3 equals 10, y equals 3x minus 2, 2 times y greater than 12, and 2x greater than or equal to y minus 3. As you're copying them, start thinking, oh, I get it. These are not algebraic expressions because, let me pick someone. Let's see. Dominique, why are those not algebraic expressions?
Because they're not simplified.
Because they're not simplified, okay. But what else do you see that is very obvious that these have different than these?
The greater sign.
The greater sign and the equal signs. That is correct, guys. These are equations. These are inequalities. That's why they're not expressions. That is correct. That's the only difference between expressions and non-expressions. Alright? So, imagine that you take a picture of this and then your BFF, what do you guys communicate with? Insta or Snap or Tweet, WhatsApp or whatever. And then you take a picture and you're going to hashtag this picture. What makes algebraic expressions algebraic expressions? Hashtag it, please, right here in the critical attributes. Do at least 3, 4 if you can. Alright. Give me one, please, Alexa. Hashtag what?
Hashtag no greater sign, like the one that's like that.
No greater sign. Yeah, I'll take that. Or no inequalities. That's another way of saying it. Thank you, Alexa. Pass someone.
Addison?
Addie?
I put hashtag just numbers.
Just numbers. Pass someone.
Alyssa?
Alyssa, this is the important one. Which one is important that we haven't done? Hashtag what?
Hashtag no equal sign.
Okay, so no equal sign. Yeah, that's also important. But there's another very important one. No equal sign. Pass someone. Who? Alright. Help us out, Miles. Hashtag what? What are we missing?
What? Huh? Hashtag constant and variables.
Okay, constants and variables. Yeah, the biggie that we were missing is a variable, right? Because if it doesn't have a variable, what would it be, guys? A numerical expression. Alright. Alright, set that aside. And now that we have algebraic expressions, so let's start with an example Q. Example Q. Copy this. Okay. Let's do negative 5x plus 9x. Okay. So first things first. I'm starting with this one. This one has an X. Is there another one that has an X? Yes, this one. Okay. So since both of them have X, I'm going to just write X down here because it's just a label. Next, is there addition in between them? Yes. Which is the smallest coefficient or the smallest number? -5 or 9? Oh, -5. So that means -5 cancel 5 of these positives, and that leaves us with 4. That becomes 4x. Another one. Example supercube. Let's do 12y plus -15y. Simplify that one, please. Oh. What happened? Oh. Okay. All right. So, let's see. This one has a y, this one has a y, so I write y. Do we have addition in between? Yes. Okay. Next. Are they opposite signs? Yes. Smallest number is 12. 12 cancels 12 of these, and we're left with -3. So we have -3y. Hands, have you got that? Alright, good. Alright. We're good with these, yes? Let's crank it up a notch. And this next one's going to be for... yes, Emily? Question? Or did your screen freeze and I'm like seeing the previous screen? Here we go. Example mega cube. Let's do 4a plus 6 plus -7a plus -4. Alright. So, for these, once again, now that we have a lot of terms, double check them, make sure that we have addition throughout. Addition here, additions here, and addition here. Yes. Alright, let's start with the first one. The first one has an A. Is there another one that has an A? Yes, it's right there, Mr. Q. Okay, I'm going to write it down over here. 4a plus -7a. Alright, so let's see. Both of them have A, so I write A. Are they opposite numbers? There's addition, opposite numbers, yes. So 4 of these cancel 4 of those, and we're left with -3. Alright, next. I have 6 here. Just a number. Is there another one that's just a number? Yeah, this one. So I'm going to write 6 plus -4. Alright. Do we have addition? Yes. Opposite signs? Yes. Smallest number is this one. This cancels 4 of these, and we're left with 2. And we just put a plus, and we're done. Alright. Not bad, not bad. See how you deal with this next one by yourself. Example Shazam cube. Let's do -5x plus -3 plus 8x plus -2. Copy that. I'll give you some time to simplify that one. Go. Alright? Let's see how we did. So, we have a lot of terms. Do we have addition throughout? Yes, yes, and yes. Okay, I'm going to start with the variable. This one has an x. Is there another one with an x? Yes. So I have negative 5x plus 8x. Are the opposites numbers, opposite signs? Yes. So I write x. Smallest number is this one. 5 of these are going to cancel 5 of those, and we're left with 3. Okay. Next, I have a constant right here. Negative 3. Is there another number? Yeah, negative 2. So I have negative 3 plus negative 2. Alright, so do we have addition? Yes. So, negative 3, are they opposite numbers? No, these are the same kind. So what do? We combine them. Negative 5. And I write plus negative 5, and we're done. Now, some of you wrote this. Some of you wrote 3x minus 5. That's also correct. But for right now, if you do either or, that's fine. Hands if you got that. Let's go. Alright. So far, with numerical and algebraic expressions, how do you feel? 1 being the lowest, 5 being the highest that you feel good. Show me with your fingers how you feel with those. 5, 5, 5s. 5, 5s, okay. Alright. Watch out. Some of you need a manicure. Not bad. Alright. Okay. Alright, so let's crank it up a notch. Yeah? Ha 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 ha. Yeah. Let's go. Let me make some room here. Example MJQ. Alright. So here goes this one. I'm going to start with a numerical only. I have negative 6 minus negative 8. Now, reminder. I mean, you guys should remember these, but here it goes again. First things first, let's check. Is there addition in between? No. Now we have a subtraction. So in order for us to use the two properties that I introduced earlier, we need to change this into addition. This becomes addition. This first number stays the same. So I write negative 6. And this second number, once we change this to addition, this becomes its opposite. Opposite. What's the opposite of negative 8? 8. So now that we have that, let's look at it. Let's work on these two. Is there addition? Yes. Are they opposite numbers? Yes. And then we have small negative 6 is going to cancel 6 of these, and we're left with 2. We good? Alright. Example, let's see, Star Wars Q. Alright, let's do 9 minus parentheses negative 11. Let's see how you do with those. Alright, let's see. Do we have addition? No. That means I'm going to change this to addition. What does that mean, Mr. Q? That the first one stays the same. And the second one, we do the what? Opposite. What is the opposite of negative 11? 11. So now, do we have addition again? Yes. Are they opposite signs? No. We combine these, so the answer is 20. Hands, have you got that? Alright. How we doing? Good? All right. Let's crank it up a notch, yeah? Yes. Switch to algebraic. Yes, algebraic expressions. So let's do example Power Rangers cube. Let's see. Let's do negative 7a minus parentheses negative 3 minus 6a minus 5. Alright, so let's start with the variable. This one is an A. Is there another one with an A? Yes, right here. Alright, so let me write those over here. Negative 7a, and this one is negative 6a. Question, is there an addition in between? No, it's a negative. So I'm going to change this to addition. This one stays the same. And this, what is the opposite of 6a? Negative 6a. Alright. So, can we combine now? Yeah. There's addition. They're the same sign, so I write A. What is negative 7 and negative 6? That's negative 13. Alright, next. Here's a constant. Is there another one or another number? Yes. Alright. However, for this one, guys, bring this next to it. So check this out. Since this is the first term, negative 3, and then this one is negative 5. Whenever you have a negative on the first term, you distribute this, so this becomes what? 3 minus 5. Okay. So here we go. Since we have subtraction, this becomes what? Addition. First one stays the same. And what is the opposite of 5? Negative 5. Alright. So, addition, yes. 3 of these cancel 3 of those, and we're left with negative 2. So, we bring this one, negative 13a plus, and what is this one? Negative 2. Alright, how are we doing? Alright? So, with that said, let's go to last week's home play. Get that in front of you, please. Last week's home play. Alright, let's go over number 6 on your home plate. Number 6. So 6 reads 5y plus 2 minus 8y minus 8. Alright, so here we go. I'm going to start with, do we have addition throughout? No. This one is minus, this one is minus, so keep that in mind. Get it? See what I did? Minus, mine. Anyways. Start with a variable, 5y, and this one is 8y. I'm going to write them over here. 5y minus 8y. Okay. So, Is there addition in between? No, so that changes to addition. First one stays the same. And what is the opposite of 8y? Negative 8y. Same variable? Yes. 5 of these. Cancel 5 of these, and we're left with negative 3. Alright, next. I have 2 here and negative 8. So I'm going to write 2 and negative 8. Question, is there addition in between? No, so that means we're going to change this to addition. First number stays the same, and what is the opposite of 8? Negative 8. Alright, so with that said, 2 of these cancel 2 of those because they're opposites, so that leaves us with negative 6. So answer, negative 3y, negative 3y negative 3, oh my goodness, negative 3y plus negative 6. Whew. Hands if you got something like that. Yes? Alright.
Mr. Q?
Yeah.
Is it okay if we put negative 3y minus 6?
Yeah, so if you wrote also negative 3y minus 6, yeah, same thing. Either way is correct. Alright? So, let's go to number 8. Number 8 looks interesting on the home plate from last week. Now that we did some practice right now, can you redo number 8 by yourself? I'm waiting for my computer's a little slow. I'm going to replace you, computer. My goodness. Alright, there's number 8. And number 8 reads 1 minus 7m plus 2x squared plus 10a plus 9m plus negative 8x squared plus negative 6 plus a plus 5. Even if you already did it on the weekend, do it again, please, so you can get some practice. Copy that and go. Alright, let's see what we got. For number 8, the correct answer in any order should be the following. Negative 6x squared plus 11a plus 2m in any order. Hands if you got something like that. Yeah, let's go. Alright. So for those of you that are still having doubts with this, I'm going to go over it step by step, but that's the simplification. Once again, negative 6x squared plus 11a plus 2m. Let me go over that. And the rest of you, you already got a head start on the home plate for tonight, so be working on that while I work on this one really quick. So here it goes. I'm going to start with 1. Is there another number by itself? Yes, it's right here, negative 6. Is there another number? Yes, right here. And what do we notice? That there's an addition, So I'm going to combine all the like terms. I have 1 positive plus positive 5, that's positive 6. So I combine 1 with 5, that gave me 6. And I bring down which ones? Plus negative 6. So what is 6 plus negative 6? Remember that rule? A number plus its opposite equal to what? 0. So these cancel. We don't need it. Okay. Next, I'm going to go with m. Is there another m? Yes, right here. And is there an addition in between? Yes. I'm going to write it here, negative 7m plus 9m. Since it's addition, they're opposite signs. 7 of these cancel 7 of those, and we're left with 2m. Next, I got 2x squared. Is there another x squared? Yes. There's addition in between, so I'm going to write them out. 2x squared plus negative 8x squared. Since both of them are x squares, I'm just going to write x squared. So they're opposite numbers. 2 of these cancel 2 of these negatives right here, so we're left with negative 6. And I'll put this in parentheses and a plus in between. And last but not least, I'm going to switch to green. I have 10a right there, and I have a positive a. So 10a plus 1a. Is there addition? Yes. Are they the same variable? Yes. And they're the same sign. So 10a plus 1a, that's 11a. Put a plus in between. That's the answer. For right now, in any order is fine. But if you went the extra step, we always arrange it from highest degree to lowest degree. So what is the highest degree? This one, negative 6x squared. From there, these two are the same degree. They're 1 and 1, but I'm going to start with alphabetical order. So plus 11a and plus 2m. For right now, either answer was correct. How's everybody doing? Good? You're like, Mr. Q, I'm falling asleep. We'll go to bed earlier. My goodness. So, that'll be our lesson for today, guys. Once again, if you have any questions, make sure you email me, or if you want to stay at the end once I turn off the recording. Actually, I'm going to turn off the recording, in a little bit. Give me a second. So hopefully that'll be enough practice for you guys for tonight. And tomorrow we're going to turn both of them in on Nearpod. Today, if you notice, we didn't log on to Nearpod so that we can just get plenty of practice in class. So hopefully that helped and that clarified some of the things that you saw last night. Okay? Alright guys, so just remember today's schedule is the same as tomorrow. We're going to have also tomorrow 1, 2, and 3. Okay? And next week is when we switch on Monday to 4, 5, and 6. So I know you're saying, Mr. Q, why do they keep switching? I have no idea. I just know that I'm here, and give me the schedule, and let's rock and roll. Yes? Alright guys, so that's our lesson for today. Get some practice tonight, get some rest, and I'll see you guys tomorrow. Peace. Alright?
See you, Mr. Q.
Later.
Later.